Hello, this is Mrs. Ward, and I am going to go over the additional semester exam review packet that was passed out last time in class. So let's start. Given the function f of x is equal to x squared minus 5x plus 2, can you guarantee that f of x is equal to 3 somewhere in the interval of -2, 5 using the intermediate value theorem? The intermediate value theorem says that if the function is continuous, so I'm looking up there and I say yes, I say the function is continuous. Then you have to meet every value from your endpoint. So if I find f of -2, so I'm putting -2 in here, so -2 squared minus 5 times -2 plus 2. When I do that, I get 16. And then when I do f of 5, that's going to be 5 squared minus 5 times 5 plus 2, and that ends up equaling 2. So in the interval from -2 to 5, I'm going to hit every number between 16 and 2. And since 3 is in between 16 and 2, then I can guarantee that f of x will equal 3. The next one is spheric ball, a balloon, is inflated at a rate of 32 pi 3 centimeters cubed per second. How fast is the radius of the balloon increasing when the radius is equal to 8? So the formula for that, and remember I will give you those formulas on the exam, are 4/3 pi r cubed. That's the volume of a sphere. So then I know what I'm given is I'm given that the change in the volume with respect to time is that 32 pi over 3 centimeters cubed per second. What am I trying to find? I'm trying to find the change in the radius with respect to time when my radius is equal to 8 centimeters. So that's my given information. So I'm going to go up here and I'm going to take the derivative. So dv dt is equal to that 3 times the 4/3 will be 4 pi r squared dr dt. So once I take the derivative, I'm going to substitute in what I know. So my dv dt is that 32 pi over 3. I'm not putting the units in while I work. And then here's my 4 pi. My r is 8 centimeters squared, and I'm looking for my dr dt. So this will be 32 pi over 3 is equal to, that's 64 times 4, so 256 pi dr dt. So I am going to divide both sides by 256 pi, or I could think of it as multiplying by 1 over 256 pi. I see that the pi's are going to simplify, and when I do all that, I ended up with 1 over 24 is equal to my dr dt. If you're a decimal person, that 1 over 24 is going to be 0.4166. That 6 keeps on repeating. Dr dt. So my units are going to be centimeters per second, and the radius is a linear measurement, so it's just centimeters, nothing squared. The next one, a conical paper cup is 30 centimeters tall with a radius of 10. The bottom of the cup is punctured so that the water level goes down at a rate of 4 centimeters per second. So my change in height is what I know. I'm given my change in height with respect to time, and that's 4 centimeters per second. At what rate is the volume of the water in the cup changing? So I'm trying to find the change in volume with respect to time. When the water level is 8, when I'm going to say water level H is 8 centimeters. So when I think of this cone, it tells me, because the volume for a cone, I should write that first. The volume for a cone is going to be 1/3 pi r squared h. So this is one of the cases where I have those two variables. But if I go to my picture, and here's the cone, cone, I did not draw a cone, my bad. Cone. and they're telling me that it is 30 centimeters tall when the radius is 10. So I'm going to sort of set up that little proportion, and I'm going to say, well, over here I'm going to say, well, the height. So I did rate 10, height 30, cross multiplied. So I have 30R is equal to 10H. I want to replace the R because everything I'm talking about has the height. So R is going to equal 10 over 30H. So R will equal 1/3 H. So I'm going to put that into this formula. So V is equal to 1/3 pi. R is 1/3 H. Forgot my H. Squared times H. And when I do that, I'm going to have 1/3 pi. That'll be 1/9 H squared times that H, just showing step by step. So this will be 1/27 H cubed. That's just the formula of the volume when I replaced the radius with the height. And now I am going to take the derivative. So dV dt. When I take 3 times 1/27, I'm going to get 1/9 H squared dH dt. So now that I've taken the derivative, I'm going to substitute in what I know. So I was given that the dH dt is 4. And I'm doing this when my height is 8. And I'm looking for the change in volume. So when I do that, oh, you know what? This height is going down, so I should probably make that negative to indicate that it's going down. It's getting less, so I will put a negative sign in there. And when I do this, I got a negative 256 pi over 9. And if you want a decimal for that, because I think a decimal would make a little bit more sense, that would be a negative 89.3609 centimeters cubed per second. So that is that one. Remember, if you have two variables, like I have this R and this H, since it's a proportional shape, they will always be in the same relation to each other, and you're going to have to substitute one in for the other just to make your life a lot easier. All right, the next one, find the absolute max and the absolute min in the given interval. Remember, if this, since this is a continuous function, I am guaranteed to have a max and a min on that interview. So to do that, I have to test my endpoints. So I'm going to test at -1 and 4. And I'm also going to take the derivative and test any critical numbers. So the first thing I'm going to do is find the derivative. So this I can write as 1/2 x squared minus 4x plus 2. So when I take 2 times 1/2, I'm going to get x. To reduce the power by 1, so it's just going to be x minus 4. That's my derivative. Now to find the critical number, I'm going to set it equal to 0, and I'm going to get x is equal to 4. So that's my critical number is 4. Well, 4 happens to be one of my endpoints, so I am going to find f of -1. So to do that, I'm putting -1 back into the original equation. And when I do that, I get -1.5. And when I put in 4, it's going to be 4 squared over 2 minus 4 times 4 plus 2. And that ends up being -6. So I'm going to have an absolute max of -1.5. That occurs when x is equal to -1, but the absolute max is -1.5. I'm going to have an absolute min of -6, and that occurs when x is equal to 4. Okay, the next one, I want to find the first, I'm going to use the first derivative test to find the relative extrema of the function. Use a table to support your work. So I am going to find, continuous function. I am going to find my derivative to find my critical numbers. So that is it. I could write plus 0, but I'm not going to. Well, I just did. So now I'm going to set it equal to 0. So 4x to the third minus 4x. I'm probably going to factor out a 4x and make this x squared minus 1. So since I'm having so much fun, let's keep on factoring. And so I'm going to get my critical numbers are going to be x is equal to 0, x is equal to -1, x is equal to +1. So I'm using the table, so I'm going to make that chart. I am going to have -1, 0, and 1. I like to put circles there to remind me that those are the numbers that I'm using for the intervals, not the test points that I come up with. I factored this as 4x, x plus 1, x minus 1, and then I'm going to leave a column for my answers. Picking test points. Two. So -2, this will be negative, negative, negative. The whole answer will be negative. -1/2, negative, positive, negative. Whole thing's positive. Putting in 1/2, whole thing's negative. Putting in 2, the whole thing's positive. So I know it doesn't ask me, but I know it's decreasing. It's decreasing on the interval from -infinity to -2, and then again it's decreasing from 0 to 1. It's increasing from -1 to 0, because these are the places where my derivative is positive, and from 1 to infinity. Ooh, I used -2. I hope somebody was yelling at me. No, Mrs. Ward, it has to be -1. All right, because I have to use these critical numbers, not the test points. So if I think about this, my function's decreasing, decreasing, decreasing. I hit this -1, and then I start increasing. So this -1, I'm going to have a relative min at x is equal to -1. I'll figure that out in a second. Then I'm increasing, 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 hit this 0, and then I start decreasing again. So I'm going to have a relative max at x is equal to 0. And then, so decreasing, 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 hit this 1, and I start increasing again. So that's going to be another relative min is +1. So that's great. I found the x values. Now I have to find the y values. So I am going to go back to my original equation, and I'm going to put in the -1 and 1. So I'm going to do f of -1, so that'll be -1 to the 4th minus 2 times -1 squared plus 2, and when I do all that, I end up getting 1. When I do f of 1, well, it's an even function, so it's I'm going to have relative mins at -1, 1 and 1, 1. And then to find the relative max, I'm going to put 0 into this equation. So I'm going to have 0 to the 4th minus 2 times 0 squared plus 2, and that'll end up being 2. So my relative max is going to be 0, 2. So the 2 is the relative max. It happens at 0. If you're not sure, I say put the ordered pair. The next one, find the derivative, use proper notation, simplify so that no negative exponents exist. So I am going to use the product rule. So I am going to leave this -2x to the 5th minus 3 alone. Taking the derivative of this, I'm going to use a chain rule, raise something raised to the 4th power. Take 4 times that. Reduce this power by 1, so this will now be raised to the 3rd power, and take the derivative of what's inside, so that'll be 10x. The derivative of 1 is 0. Plus, now I'm taking the derivative of this guy, so 5 times -2 will be -10x to the 4th, because I have to reduce that power by 1. Derivative of -3 is 0, and then I'm going to leave this 5x squared plus 1 to the 4th alone. I am going to factor out what I can factor out. And from here, I see a 10x, 10x. So I'm going to factor out 10x. And then I also have this quantity of 5x squared plus 1. Here it's raised to the third. Here it's raised to the fourth. So I'm going to factor it out to the third. Okay, so in this first one, I factored out this 10x. I factored out this to the third. So I'm left with 4 times negative 2x to the fifth minus 3. And then plus, I factored out 10x, but I still have this negative sign. So I'm going to put that there. And I still have x to the third, because there's x to the fourth. And then I have one of these guys left, 5x squared plus 1, because I only factored out to the third power. So I have 10x times 5x squared plus 1 to the third. Here I'm going to distribute, so I'm going to have negative 8x to the fifth minus 12. And then here, distributing the negative, I'm going to have negative 5x to the fifth minus x to the third. So when I combine my like terms, negative 8, negative 5, I'm going to have negative 13x to the fifth minus x to the third minus 12. I might factor out a negative sign. I didn't, so there it is. There's my answer. Okay, moving on to number 7. I am going to use the chain rule, so I'm taking the derivative of something raised to the 1/3 power. So when I do that, I'm going to have 1/3 times that 3x squared plus 1, reduce the power by 1, so that'll be negative 2/3. Then look inside and take the derivative of what's inside. So take 2 times 3, get 6x. The derivative of 1 is 0. If I rewrote this and I multiplied these two, I would have 6x over 3x squared plus 1 to the negative, oh, now it's positive 2/3 because I brought it down to the denominator. I have everything in my numerator, everything in my denominator. Now I'm going to start simplifying. The 6 and the 3 can simplify, and I'm left with 2x over 3x squared plus 1. This whole thing raised to the 2/3 power. Moving on to the next one. Here I have the chain rule, and I'm going to have to take the derivative of something being raised to the 5th power and then use the quotient rule. So when I do this, I am going to take something raised to the 5th power, so that'll be 5 times whatever that is. Reduce that power by 1, so now I'm going to reduce this to the 4th power. Then take the derivative of what's inside, so I'm going to leave the denominator alone. Take the derivative of the numerator, which will be 5x to the 4th, minus, leave the numerator alone, and take the derivative of the denominator, which will be negative 20x to the 3rd. And then this is all over my denominator squared. So when I write things on the numerator, write things on the denominator, clean up a little bit, I'm going to have 5. I like to write this x to the 5th minus 2 to the 4th. And then here's my big denominator. And then this is negative 5x to the 4th plus 2. That is also being raised to the 4th power. I like to separate that so I remember that the denominator is being raised to the 4th power. Here, I distribute the 5x to the 4th. So this will be negative 25x to the 8th. Plus 10x to the 4th. Then this, can I do this? The negative times the negative will be positive. I think that'll make my life easier. So I'm going to have 20x to the 8th minus 40x to the 3rd. So when I multiply, combine like terms, so I end up with negative 5x to the negative 5x to the 8th plus 10x to the 4th minus 40x to the 3rd. I think that's right. I hope that's right. Then there I realized that I could factor out a 5. So I'm going to factor out a 5. Factor out a 5 from here. So I'm going to, the 5 that I factor out will make this 25. So this will be 25 x to the 5th minus 2 to the 4th. I wonder if I should factor out a negative. No, I'm not going to. So this will be Oh, you know what? I should factor out 5x to the third. So I think I will. So this will be 25x to the third. Then I factor out 5. So this will be negative x to the fifth plus 2x minus 8. And this is all going to be over negative 5x to the fourth plus 2 raised to the fourth power. Number 9 is a baby problem because I'm just doing the quotient rule. So I'll take the derivative, leave the denominator alone. Oh, yeah, I do want to do that. Take the derivative of the numerator, so that'll be 8x and just 8x minus, leave the numerator alone. Take the derivative of the denominator, which will be 10x to the fourth, all over my denominator. And can I write my denominator as 2 times x to the fifth plus 2? And that's all going to be squared. I can do that. All right, so here I am going to, between here and here, I don't know if you want to do this before or if you want to wait until you're done, but I'm going to factor out a 2x while I'm at it. I wonder if I should. Probably shouldn't. Let's not do that. Change of mind. I can change my mind. So we'll just distribute the 8 and then factor out later. So if I do this, this will be 16x to the 6th plus 24. Oh, that's 32. Bad math. 32x. Distributing in negative 10x to the 4. So this will be negative 40x to the 6th minus 30x to the 4th. And this is all over. If I square this, this will be 4. And then x to the 5th plus 2 squared. I can combine my like terms. So if I can combine my like terms, the positive 16 with the negative 40 is going to be 24. Negative. Minus 30x to the 4th plus 32x. And this is all over 4 times x to the 5th plus 2 squared. I am looking at the numerator. I can factor out x. I can also factor out a 2. Is that all I can factor out? I think that is all I can factor out. So I can factor out 2x. And I'm going to have negative 12x to the 5th minus 15x to the 3rd plus 16 all over 4 times x to the 5th plus 2 squared. Now the 2 and the 4 will simplify. We're left with this. And that is my final answer. Moving on to number 10. Number 10, it says find the intervals in which a function is continuous. So I didn't read the directions at first, and I just started going all crazy. I don't even have to find the derivative of this. I just have to look at my denominator. So I'm going to factor that as x minus 3, x minus 4, 1, minus 1, using product sum. And then the places where my denominator is equal to 0, so it's going to be discontinuous when x is equal to 3 and x is equal to 1. Those are the two places whenever it's discontinuous, because it's two places that makes the denominator equal to 0, and you can't have division by 0. But if I were to write this as x minus 1 over x minus 3, x minus 1, I can see that the x minus 1s will simplify. So it's going to be a removable discontinuity. X is equal to 1, which means I'm going to have a hole. I'm probably not even going to see it when I graph it on my calculator. And I'm going to have a non-removable discontinuity at x is equal to 3. And remember, that creates a vertical asymptote. And then you write the equation of the vertical asymptote, which is x is equal to 3. So no derivative necessary, just looking at, that's one of the very first things that we did, was talking about the types of discontinuity and when a function is continuous and when it's not. So number 12 is the same directions, discuss when it's discontinuous. So this is a piecewise function. My breaking point, or where I change the rules, is where this x is equal to -2. So I'm going to do -2 plus 1, and I get -1. I do -2, oh no, I do +2 times -1 plus 2. Oh, Beth, what are you doing? You do 2 times -2, there we go, plus 2. You're just putting 2 into that equation. So that's -4 plus 2, and I get -2. So since those do not equal each other, and I made a mistake on the answer key, so remember that. Since these two do not equal each other, it's going to be discontinuous at x is equal to -2, and this is where you have that jump. So I'm going to have an equation of a line that goes like this, something like this, and then at -2, I'm going to have this hole, and then my life will go on. And no, I'm sorry. That's when x is equal to -1. So there, and then I have the hole there, and then I will have, why am I having such a struggle today? And then the equation will go something like that. So I'll have a hole here, I have that jump where they don't connect. If these two numbers were equal the same, then it would be a continuous function. Okay, the next one I am going to factor, and that factors is x plus 3, x plus 1, all over x plus 1. So it's discontinuous at x is equal to -1, because that's what makes my denominator equal to 0. But since it simplifies, it's going to be a removable discontinuity. And you can check this on your calculator. If I graph this whole function, here, and I graph just y is equal to x plus 3, the graphs are going to look exactly like, they're going to be right on top of each other. The only time that you're going to see that there's a difference is when you go to the table and you look at x is equal to -1. For this whole thing, it's going to say undefined. For x plus 3, it's going to tell you that it's equal to 2. So that's the only way you can find a non-removable discontinuity when you're looking at your graph, is to actually look at the table. Okay, for 14, we're using implicit differentiation. So I'm going to do 15x squared is equal to 6y dy dx, and the derivative of 5 is 0. So now I'm going to solve for dy dx. So I'm going to take this 15x squared and divide it by 6y. That's going to equal my derivative with respect to x. I can simplify and make this 5x squared over 2y, and I will. And that is my final answer. So that was a baby one, right? There was no hard things with this. Number 15, I have to remember to use the product rule, and that is the biggest mistake, is you will forget to use the product rule. I'm going to leave that 4x to the third alone. Taking the derivative of y squared, that'll be 2y, and then dy dx, because I took the derivative of the y function. Now I'm going to take the derivative of that 4x cubed, which will be 12x squared, and leave the y squared alone, is equal to 15x squared plus, using the product rule again, leave the 4x squared alone, take the derivative of y, just dy dx. Now take the derivative of 4x squared, which will be 8x, and leave the y alone. Okay, so I'm going to clean this up. This is going to be 8x cubed y dy dx. Everything else will stay the same. And then I don't know if you're a highlighting person or what, but anything with the dy dx, I'm going to take to the left side. Anything that does not have the dy dx is going to go over to the right side. So on the left side, I'm going to have dy dx, and then I'm going to have this 8x cubed y. And then I'm bringing this over to this side, so I'm going to do minus 4x squared. That's everything with the dy dx. This is going over here, so negative 12x squared y squared plus 15x squared plus 8xy. I am going to divide both sides by this 8x cubed y minus 4x squared. I'm doing the same thing over here. I am going to factor some stuff out while I do that, if you don't mind. So when I do this, I am from the numerator, I can factor out an x, and that's it. I think that's all I can factor out. So I'm going to factor out an x and make this negative 12xy squared plus 15x plus 8y, because I factored out the x. And in the denominator, I can factor out a 4x squared. And when I do that, I'm going to have 2xy minus 1, because I factored out that whole thing. Now I can simplify one of the x's, and I'm going to have negative 12xy squared plus 15x plus 8y all over 4x, then 2xy minus 1. And that is my derivative in lowest terms. I hope this helps. And if you have any questions, remember, come see me. Thanks. Bye.